Section 4.3, linear equations and two variables. Now in 4.2 we took a look at graphing equations when given to you in what is called standard form, and that was a pretty useful method when they are in that form. Here in 4.3 we're going to look at graphing equations when they're given to you in what's called slope-intercept form, and when this is the case it makes more sense to use a different approach. First we can just review what is slope-intercept form. It's when you have an equation in y equals form, when the y is already by itself, and everything else, the x term is on the other side, and also some constant term that might be some number by itself. When you're in this form, slope-intercept, and you have y by itself, y equals, the m value, the coefficient of x, the number out in front of x, that tells you your slope. Also the number that's by itself, which we're calling the b value here, could be either a positive or a negative, could be plus or minus, that tells you your y-intercept. More specifically, it gives you the y-coordinate of your y-intercept. So it tells you your y-intercept is 0, b, whatever positive or negative number that b value happens to be. So using that as a basis, we're going to graph a couple equations that are given to us in slope-intercept form. So first example. Write the equation of a line with slope -4/5 and y-intercept 0, -2. Then graph it. Well, first things first, let's write the equation. And where you're given enough information, we can go right into slope-intercept form. So, let's take what we have and write it in y equals form. If our slope is -4/5, that tells us the number that's going to be attached to x. And then the y value of our y-coordinate, or the y-coordinate of our y-intercept, is -2. So that means on the end of this equation we're going to have a -2 rather than a +2. So then we want to graph this equation. -4/5, y equals -4/5 x minus 2. First things first, we can view the y-intercept as a starting point. That tells us where to begin on our y-axis. So, at -2, our y-intercept, again, that gives us our starting point. On the y-axis. So we can come down here to the point 0, -2, and recall this is our x-axis, this is our y-axis. So come down here to the point 0, -2 and plot our y-intercept. I'm also going to mark that point 0, -2. So from there, we then can use the slope to tell us how to move from point to point. And to do that, we want to think of our slope as rise over run. So our slope is our m value, the number attached to x, which is -4/5. So we want to think of this as m rise over run, -4/5. Well, if you recall when we were using slope in section 4.2, the rise top value of our fraction tells us how much we're moving up or down. Negative value, so we're moving down 4. And the bottom value, the 5, tells us how much movement we're running. In other words, movement to the right. So we're going to be moving 5 units to the right. So from the point we already made, 0, -2, our y-intercept, we're going to be coming down 4, 1, 2, 3, 4, and to the right 5, 1, 2, 3, 4, 5, getting us right there. That would be the point 5, -6. Okay. And now once we have 2 points, we can draw a line through them, and that's going to be the line representing the equation y equals negative 4/5 x minus 2. So let me draw this in, though, to remind us our movement. We move down 4 and to the right 5. Our actual line, though, is going to be the line that crosses those 2 points. So, the red line I just drew in represents the equation y equals negative 4/5 x minus 2. So you see, when you have an equation given to you in slope-intercept form, it makes it maybe a little bit easier to graph the equation. You go ahead right away, plot your y-intercept, your starting point, based on what number is by itself, and then you use the slope to move from point to point, or to move from that y-intercept to the next point. And of course, your slope is always that number attached to x. Alright, let's take a look at another example of an equation graphing in slope-intercept form. And that's the equation y equals 3x minus 6. Let's graph this. So we want to use the same idea, same approach. We use our y-intercept from the equation, the b value, to tell us our starting point, our y-intercept. So in our equation here, negative 6. This is where we're going to start. So we'll go to our graph, our coordinate grid, and let's start with the points 0, negative 6. That would be down here at negative 6 on our y-axis. From there, we want to use our slope to graph at least one more point. So in this case, our slope is the number that's by itself. Or excuse me, the slope is the number attached to x, which is 3. So our x is coefficient of 3. We want to use the idea of rise over run. In this case, it's just 3. It's not a fraction. However, we can take any whole number and think of it as a fraction by simply putting it over 1. So it helps in this case, taking your slope as a whole number, putting it over 1, which is the same thing as saying 3. But then that reminds us to move from our original point, 0, negative 6, we're going to be moving up 3 and to the right 1. So our original y-intercept, 0, negative 6, we're going to be moving up 1, 2, 3 over 1. That technically is all we need in order to draw the line, but sometimes problems will ask you what is the what is the x-intercept in addition to the y-intercept. Remember, the x-intercept is going to be where the graph crosses the x-axis. We already know our y-intercept, where it crossed the y-axis at 0, negative 6, but if we wanted to know our x-intercept, we could keep moving in the same way we just did. Take the second point we made, and again go up 3, 1, 2, 3 over 1. That right there gives us our y-intercept, or sorry, x-intercept. So if they wanted to know that information, we could have told them it's the point 2, 0. And even if you want to continue making points, 1, 2, 3 over 1, and you could make a fourth point. But again, only 2 points really are necessary in order to draw the line. It's going to be the same line, though, whether you draw 2 points in, or 3 points, or 4 points. So now we want to come here, draw a line through these 4 points, and the same line that would connect 2 of the points should connect all 4 of the points. And that is graphing lines in slope-intercept form. And in the second video of 4.3, we'll look at another form of equations, which is called point slope. And we'll look at that next.